Hi friends, here in this video I'll be explaining the problem on resultant for parallel force system. So let's get started. Now here is a question in front of us. It is given that find the resultant in magnitude and direction for the following force system. So here a diagram is given in which we can see all are parallel forces like 10 kilonewton which is acting upward, 20 kilonewton acting downward. Similarly 30 kilonewton is acting upward, 50 kilonewton downward, and 80 kilonewton is acting upward. Now for this we have to find into the given force system. I will write down that as data. How much is the magnitude of resultant, which is denoted by capital R, and what is its location? Location is given by horizontal distance x. Now when we solve such a problem, we can see that there are only vertical forces, so resultant would also be there in the vertical form, and that would be written as that. Originally when we see that since the magnitude of resultant is given by it is root of summation fx square, which is the sum of all horizontal forces, plus summation fy square, the sum of all vertical forces. Now when we look into the diagram, there are only parallel vertical forces given, so summation of fx would become 0, and finally resultant would be left with root of summation fy square, and that is, when we take the root, it would be summation of fy. And this is due to summation fx being 0. Now when we are finding the resultant, that is equal to summation of fy, the condition is, or the sign convention would be, all upward forces would be treated as positive and downward forces as negative. So therefore resultant would be, this 10 kilonewton force is acting upward, so that is positive. 20 is acting downward, so negative. 30 kilonewton acting upward, again positive. 50 is acting downward, so negative. 80 is acting upward, so positive. So when I add up all the values, the answer of resultant force comes out to be 50 kilonewton. And since this answer is positive, it means the resultant is acting in the upward direction. So that would be the first answer. After this, we have to find the location of the resultant. For that, I would be using the Varignon's theorem of moments, which says that now Varignon's theorem of moments is, it says that when we take the moment of, or the addition of moment of all the forces about any single point, that is equal to the moment of resultant. So I'll say that here I am taking the first force as the reference, and I am calling this point as point A, which would be the reference point, and I would be taking the moment of all forces about this point A. So the Varignon's theorem of moments would be written as summation of moment of all forces about point A is equal to the moment of resultant, which is resultant force into its horizontal distance, which is x. Because the resultant is vertical, so its location would be given horizontally. Here when we are finding the summation of moments, the convention is clockwise moments to be treated as positive and anti-clockwise as negative. So therefore onto the left hand side, the moment of this 10 kilonewton force would be 0 because it is passing through the same point, so no perpendicular distance between point A and 10 kilonewton force, its moment is 0. Next, when we have 20 kilonewton, it would be producing a moment in clockwise direction about point A. So that is plus 20 into 1. Then 30 kilonewton acting upward. It would be producing anti-clockwise moment and the distance is 2 meters. So it is minus 30 into 2. Then there is 50 kilonewton acting downward and it would be it is at a distance of 3 meter. So producing a clockwise moment. So plus 50 into 3. Then we have 80 kilonewton force acting upward at a distance of 5 meter from point A, and it would be producing again an anti-clockwise moment. So minus 80 into 5. So this is the left hand side. Now onto the right hand side, the moment of resultant. Since the answer of resultant is positive, that is acting upward, so resultant can be anywhere. I am assuming that it is somewhere over here acting in an upward direction, and its distance from point A would be x. So the moment produced by the resultant would be negative because it is in an anti-clockwise sense. So minus resultant into distance x. Therefore, and now when we see, this would be 20. Resultant is 50 into x. So when I calculate this, I am going to get the answer of x, which is 5.8 meter, and it is with respect to the point A because that is the reference point. That's the second answer. Now, what is the meaning of this answer is that we have 5 parallel forces. Replacing them would be a single force, which is the resultant force. So taking reference from the first force, which is 10 kilonewton and upward. Now with respect to it, which is having point A, there is a force acting in an upward direction having the value of 50 kilonewton, and it is located at a distance of 5.8 meter with respect to point A. So all those 5 forces would be replaced by a single force called as the resultant, acting at 5.8 meter from point A, and this single force would be having the same effect as the combination of other forces. So that was a short problem regarding the parallel forces. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.